Let's take a look at a quadratic. ax squared plus bx plus c equals 0. And from another video, this is our, what do we call this one? Leading coefficient, which is also the quadratic coefficient. This is our linear coefficient, and this is our constant. And now a, b, and c can be any numbers. Well, what we want to look at here is how are we going to derive the quadratic formula. So let's do it. Eventually we're going to complete the square here. So I'm first going to move this constant to the other side by subtracting it from both sides. So that gives me ax squared plus bx equals the opposite of c, or negative c. Now, when completing the square, this a value has to be 1. So in order to, let's change the color here, in order to guarantee that this is going to be 1, we need to divide by a, and that's a law of algebra. If I do one thing to one side of an equation, I have to do it to both sides. And now when I divide a divided by a, it guarantees that I'll have a 1 as my leading coefficient, and that will allow me to complete the square. So now let's take a look at what I have. I now have x squared plus b over a x equals negative c over a. Okay, let's go back to black. Alright, now to complete the square, I want to take the linear coefficient, cut it in half, and then square it. If you want help on completing the square, we can do another video about that. So when I cut it in half, that gives me b over 2a, and when I square it, that's what we have. And now I need to make sure that I do that same addition. What I'm going to do here is I'm going to actually apply the exponent to the numerator and the denominator. And now let's rewrite this. This is now a perfect square, so we can write it as a binomial squared. And here I want to achieve a common denominator. So I'm going to multiply this term right here by 4a over 4a, which will give me 4a squared here. So now I have negative 4ac plus b squared all over 4a squared. Okay, let's move this down a little bit. Now, at this point I'm going to take the square root of both sides. And when I take the square root of a perfect square, that leaves me with x plus b over 2a. And now I will have plus or minus the square root of this entire expression. And I'm also going to apply commutative property here so that I can write b squared minus 4ac as my numerator all over 4a squared. Now, we're nearing the point here where we're going to solve for x. That was the whole idea here, is that we were going to take this quadratic and derive the quadratic formula, which means how do we solve for x for any quadratic. And so now I'm going to subtract b over 2a, which leaves me with x on this side. And now on the right side I have negative b over 2a. And at this point I'm actually going to take the square root of this denominator, because this denominator is a perfect square. So the plus or minus I'm going to leave right here, but this is no longer under the radical. The square root of 4a squared is a perfect square, so that gives me 2a. This is going to remain under the radical. b squared minus 4ac. Now we have a common denominator. Let's combine like terms. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And here's our quadratic formula. And let's look at a little bit more vocabulary. This is going to be the subject of a whole other video. Under the radical here, b squared minus 4ac, for any quadratic, this is called the discriminant. Nice spelling. Alright, fail. Let's try that again. Oh wait, I got a good idea. Where's my text tool? Is this it? Thank you. Alright. Now this, the negative b over 2a, is another important piece to the graph of a quadratic. Negative b over 2a is always going to give us the x value of the vertex. And then to get the y value, we simply find f of negative b over 2a.